Ji, Assalamu alaikum guys. Let's start with our today's lecture. Today we are going to study absolute shear stresses. So let me start the recording. So Bismillah Rahman Rahim. Let's start with our today's lecture. We are going to study absolute maximum shear stress, and this is heading 9.5 of the book. So this is the last topic of this chapter as well. So absolute maximum shear stress. So there are different scenarios. So we have to consider all these. So let's start with it. Everyone can see the shared screen?
Yes, sir.
Okay. First thing is absolute maximum shear stress. A body subjected to a general three-dimensional state. So if you have triaxial stress state in which you have x, y, and z planes. Okay? So that is your three-dimensional state of the stress in which you have one value of the normal stress, sigma, let's say sigma x, and you have two values of the shear stress components, that is tau x y and tau x z. Okay? So on each face you had one normal stress and two shear components, stress components. Similarly, on y face you will have sigma yy and tau yx and tau yz, and on the z face you will have sigma z or sigma z and tau zx and tau zy. So that was over three-dimensional state of the stress. Okay? Now in our case of plane stress state, in our case of plane stress state, it is biaxial stress state. Means you are working in xy plane, and in that case you have two normal stresses and one shear stress. So in our case of the plane stress state, that is biaxial stress state, material is considered the material or the element to be subjected to the in-plane principal stresses. Okay? So in-plane principal stresses, they are basically your normal stresses. You can see this. So if you focus on this figure, so you have a triaxial element, x, y, and z axis. Okay? Overcase is simplified to biaxial scenario. Overcase is simplified to biaxial scenario. So you can see there are these normal stresses, or you can say here we are calling these normal stresses as over major principal stress and minor principal stress. So you can see we are assuming that there is a major principal stress acting along x-axis and minor principal stress acting along y-axis. But there is no stress acting along the z-axis. So there is no stress acting along the z-axis. So I only have a stress, normal stress about x and normal stress about y-axis. Now this is case 1. Case sigma 2, both are tensile in nature. Both are tensile in nature, means they are going to produce elongation in the element. They are acting away from the face. Okay? So both these stresses, sigma 1 and sigma 2, they are tensile in nature. Now, this dimension has been drawn in two dimensions. So we started with this YZ plane. So you have this Y and Z plane, and as you can see from this, there is no normal stress acting along the Z axis. There is no normal stress stress acting along the y-axis, and that is sigma 2. So in two dimension, I can represent that as sigma 2, ठीक है जी, acting along the y-axis, and there is no normal stress or stress acting along the z-axis. Then I can draw this x and z plane. X and z plane. So you can see in x and z plane, I have one and I know principal stress. In the z-axis, no stress. ठीक है जी? So in z-axis, I have no principal stress. Only I have stress along x-axis, sigma 1. Now, if I want to draw this x and y. Now, on the x-axis, you have sigma 1, and this that sigma 2 is tensile in nature. In the element, similarly here, along the x-axis, sigma 1 will cause the elongation. It's tensile in nature. In xy plane, I have along the x, I have sigma 1. Along the x, I have sigma 1. All these stresses are tensile. They are going to produce extension or elongation in the element. Are these four figures clear? If you have any query about figures, please ask me now. If this is clear, just one more thing to be noted, that the principal stress, this is clear. If we view the L2 dimensions, that is x, you have seen that we have viewed the element in yz, xz, and xy. Now we have these three scenarios. If we view the element in two dimensions, then we can use the Mohr's to determine the maximum in-plane shear stress. Basically, over plane shear stress and absolute value of the maximum shear. So principal stresses or normal stresses we are getting from here. We just want to know over maximum in-plane shear stress and over absolute value of the maximum shear stress. So if we view the element in two dimensions, x, y, y, z, or x, z, all these three cases, then we can draw more circle to determine the maximum in-plane shear stress for each such case. And then we can determine the absolute maximum shear stress. Then we can determine the absolute maximum shear stress in the element. Now, these are the three more circles which we have drawn. So just starting from very basic, x-axis is my normal stress, which will be principal stresses here. Y-axis is my shear stress. So I have to draw more circle for each case. More circle for each case. So let's start with this case. Case B, where you have YZ plane, there is sigma 2 acting along y-axis. So it means there is a normal stress sigma 2 and stress about z-axis is 0. So a Mohr circle can be simply drawn here. 0. So in this case, you can see 0 represents the normal stress in the z-axis, and this is sigma 2. Sigma 2 represents the normal stress in the y-axis. That sigma 1 is over major principal stress and sigma 2 is principal. So this is my Mohr circle for YZ plane. This is my circle for YZ plane. And the maximum shear stress, as we have determined, that it will be equal to the radius. Okay, so the maximum stress tau YZ dash maximum. So that will be this one, and its value will be from 0 to this is sigma 2. So this will be sigma 2 over 2 because this total is the dia sigma 2. So this is absolute maximum shear stress will be radius d by 2. So sigma 2 divided by 2. So this is the maximum shear stress for the tau YZ plane. Now next is I draw the Mohr circle for the second scenario XZ plane. Sigma 1 is my principal stress, and along the z-axis I have no stress. So for this second scenario, again Z represents zero stress, and this outer big one that represents my Mohr circle for XZ plane. ठीक है जी, Mohr circle for XZ plane, this outer one. ठीक है जी, so this is 0 and the dia is equal to sigma 1. So maximum shear stress will be this one, tau XZ dash, tau XZ dash, and this one will be equal to क्या होगा जी इसका sigma 1 over 2. Total dia of this second circle is 0 to sigma 1, and the maximum shear stress is tau XZ dash, which will be equal to sigma 1 over 2. Is this point clear? Is this point clear?
Yes, sir.
Yes, sir.
Okay. Now the third scenario is XY plane. Third scenario is XY plane. ठीक है जी, XY plane, and in XY plane you have sigma 1 in the axis, and you have sigma 2 in y axis. So now the Mohr circle for this one will be this inner one. ठीक है जी, connecting sigma 1 and sigma 2. This third inner circle, this inner circle is the Mohr circle for XY plane, in which sigma 1 and sigma 2 both are acting. And the maximum shear stress in this case will be sigma 1 minus sigma 2. This will give you the dia divided by 2. So this will give me the maximum shear stress in XY plane. Now we wanted, now you have 3 Mohr circle, and corresponding to each Mohr circle we have the maximum shear stress, maximum shear stress. Now we need the maximum in-plane shear stress and shear stress. We need to absolute and the maximum plane shear stress. First, let's see which one is absolute maximum shear stress. Absolute maximum shear stress is the largest of these 3 shear stresses. You can see this. This is tau YZ. This is tau XY. This is tau XZ. This one. So larger of the 3 is this one, tau XZ maximum. So the larger of the 3 is this one, tau XZ. ठीक है जी? So my absolute maximum shear stress will be this one, the larger of the 3, that is tau XZ dash, and magnitude of this will be 0 minus sigma 1 minus 0 over 2. So this will give me the absolute maximum shear stress. Is this point clear? This is my absolute maximum shear stress. ठीक है जी, sigma 1 over 2. Now maximum in-plane shear stress. Maximum in-plane shear stress will be the one which will include x and y axis, because we are working in biaxial stress state condition, x and y plane. So my maximum in-plane shear stress will be the one which is sigma 1 and sigma 2. So this one will be my maximum in plane shear stress, that is sigma 1 minus sigma 2 over 2. Always remember this, maximum in plane shear stress will include both x and y axis, or you can say it will include both sigma 1 and sigma 2. And my absolute maximum shear stress will be the case in which you have the shear value of the shear stress. ठीक है जी. Now written this that for all circles it can be seen that the maximum in plane shear stress is the one which will include x y plane, and it will include maximum principal stresses. So maximum in stress that we saw x dash y dash, that will be sigma 1 minus sigma 2. This will give the diameter, will be the radius. Sigma 1 minus sigma 2 over 2. And absolute maximum shear stress. Absolute maximum shear stress is this one. And this is sigma 1 minus 0 over 2. ठीक है जी, sigma 1 over 2. The same we can see from the book as well. See this. First, they have defined the triaxial stress state. In the triaxial stress state, they have first defined that at each phase you have one normal stress and two shear stresses. ठीक है जी. So you can see you have y, x, and z phases, and on all the three phases you have one normal stress and two shear stress. One normal stress and two shear stress. ठीक है जी. Then they have shown this triaxial stress. In over case it is biaxial. So we have just simplified the case in this way. You can see the sigma 2, it is acting along the y-axis. This is sigma 1, the major principal stress, acting along the x-axis. Then they have shown this in the form. Of biaxial planes. Z and y plane, and you can say there is only sigma 2 acting along the y-axis. There is no stress acting along the z-axis. Then you have this x and z plane, and you can see normal stress sigma 1 is acting about the x-axis, and there is no normal stress acting about the z-axis. Then you have the third scenario, x and y. There is a normal stress sigma 1 acting along the x-axis, and there is normal stress sigma 2 acting along the y-axis. ठीक है जी. Then they have drawn these three circles, more circles. This smaller one is 0 and sigma 2, that is basically representing this scenario. ठीक है जी. And this is represented as tau y dash z dash shear stress in maximum in plane shear stress in y and z axis. ठीक है जी. This one circle, and this larger outer circle, second scenario, that is this one, x and z. And maximum shear stress is tau x dash d dash maximum, whose magnitude will be sigma 1 minus 0 over this value. You will get this value. ठीक है जी. Then the third scenario is x and y, in which you have sigma 1 about x-axis and sigma 2 about y-axis. So you have sigma 1 in xy plane. So this is your maximum shear stress in xy plane. Now we wanted absolute maximum shear stress. Absolute maximum shear stress will be larger of the three. 1, 2, 3. So you can visually see that x dash d dash maximum is the larger of the three, and this is your absolute maximum shear stress. This is your absolute maximum shear stress. And maximum in plane shear stress in over case will be the one which will include x and y-axis. So maximum in plane shear stress will be the one which will include sigma 1 and sigma 2. So this is my maximum in plane shear stress. Magnitude will be sigma 1 minus sigma 2. This will give me the dia, divided by 2 will give me the radius. Sigma 1 minus sigma 2 over 2. So this is my maximum in plane shear stress. And this one is my absolute maximum shear stress, which is sigma 1 minus 0 divided by 2. Is this case clear? If you have any query, please let me know. Any query? If this is clear, then I am proceeding further. And you can see this is absolute maximum shear stress value. Sorry, after first case है. Absolute maximum shear stress आपका आ रहा है जी sigma 1 over 2, and maximum in plane shear stress will be sigma 1 minus sigma 2 over 2. So this was the first scenario. In the first scenario, both your principal stresses sigma 1 and sigma 2 were positive. Now comes the second scenario. Guys, I will scan these pages again, and then I will send a PDF of the scanned pages of all the things which we have done. Although it's the same as the book, but I have also rotated. I have also solved all the numericals which we have covered in the class. So the second scenario. Now, second scenario is you have sigma 1 and sigma 2. Now, earlier sigma 1 and sigma 2 they were both positive. Sigma 1 and sigma 2 were both positive. Okay, guys, if in this case both sigma 1 and sigma 2 would have been negative, then even then you would have got the same condition, same figure, but they would have been on the negative side. But your absolute maximum shear stress and maximum in plane shear stress would have been same. You get it? Now in the second scenario, we have sigma 1 and sigma 2. Sigma 1 is over major principal stress, sigma 2 is my minor principal stress. Sigma 1 is positive. Positive means it is tensile in nature. Sigma 1 is positive, it is tensile in nature. Sigma 2 is negative, it is compressive in nature. Sigma 2 is compressive and it is negative in nature. ठीक है जी, sigma it is negative in nature. ठीक है. Now, if I draw all the three phases, guys, should I draw this figure on the whiteboard? इसमें आपने ये चीज नोट रखनी है कि sigma 1 is positive, sigma 2 is negative. So when I will have a YZ, so I will get this Mohr circle. You can see compressive is negative, sigma 2 is Z is 0, and sigma 2 is YZ maximum will be 0 minus sigma 2 over 2. ठीक है जी, minus sigma 2 over 2. You have the second sigma 1 is positive, ठीक है जी, and you can show this 0, Z is 0 and sigma 1 is positive. ठीक है जी, this second circle represents 0 to sigma 1. So X maximum. ठीक है जी. Then the third is X and Y plane, sigma 1 and sigma 1. Mohr circle which is connecting sigma 1 and sigma 2. This outer Mohr circle which is connecting sigma 1 and sigma 2, and sigma 1 minus sigma 2. ठीक है जी. So maximum shear stress in XY is sigma 2 over 2. Now if you see absolute maximum shear stress, the larger of the three is this one. This is the larger of the three. So absolute shear is this one, sigma 1 minus sigma 2 over 2. And similarly, the maximum in plane shear stress is the one which includes X and Y, which includes both sigma 1 and sigma. Same. Is this clear? Maximum in plane shear stress and absolute maximum shear stress, they are both same here. Sigma 1 and sigma 2 have the opposite. You can see sigma 1 is positive, sigma 2 is compressive, negative. So you can see now in this case, your absolute maximum stress and your maximum in plane shear stress, they are both same, and the magnitude of this will sigma 1 minus 2 over 2. Either of them has the opposite sign. 3 of the stress for that we have shown here. So absolute maximum and maximum in plane shear stress, sigma 1 minus sigma 2 over 2. Is this point clear? Is this point clear, guys? Clear? Let me draw the figures. We have the time now. I can draw the figures. It will take just few minutes for me to draw the figure, and it will be further be cleared. Okay? You can also draw the figure so that everything is clear for you. It's just downloading. I think we did not delete the figure last time. Yes, that's why it is taking time. So first, I'm going to explain principal stresses sigma 1 and sigma 2. Okay? Both have same sign. So both are either negative or both are positive. ठीक है. So this is my z-axis. This is my x-axis. And this is my y. G. Any confusion? Okay. Then now we have principal active. So this is my principal stress sigma 1. So this is tensile in nature. ठीक है जी. And this is my second principal stress. Minor principal stress is this is sigma 2, and both cases are positive. Both will result in the elongation in the element. So now this three-dimensional will split it into two-dimensional. So let's first draw this zx. So for this zx case, so this is my x-axis, this for element. You can see there is no principal stress about z-axis, so no principal stress. However, there is sigma 1 acting along x-axis, so this is sigma 1, and it is tensile in nature. So I have represented it like arrows pointing away from the element, so this will result in the elongation. Then we have second case, that is let's say z and y. So this is your z, this is your, so this is my element. Okay. So in the z you can see there is no principal stress. However, along the y I have sigma 2. I have sigma 2. ठीक है जी, and this is also tensile in nature. Then I have the third case, x and y. X and y. So this is y-axis, this is x-axis, x and y, and in this case x and y, I have sigma 1 acting along x-axis. ठीक है जी, this one. So this is your sigma 1, and this one is acting along y-axis. So this is my sigma 2. ठीक है जी, this is my sigma 2. Fine. Now I will draw the Mohr circle. Now I will draw the Mohr circle corresponding to these three. So this is my shear stress axis, ठीक है जी, and this is my normal stress. Fine. So first we draw this. We can draw this one, ZY plane. So in this you have sigma 2 positive. Always sigma 2 will be smaller than sigma 1. So this will be, just a moment please. ठीक है जी. So this is my 0 and this is my sigma 2. ठीक है जी. This is my sigma 2 and this one is, ये आपका क्या होगा जी? This is your tau. This is tau y dash z dash maximum. ठीक है जी. tau y dash z dash maximum. Okay, now in this case, now the second one is xz and you have sigma 1. ठीक है जी. So z again 0. ठीक है जी. So this is 0 and this point will be your 1. This point will be your sigma 1 and shear stress will be this one. ठीक है जी. ये आपका क्या होगा? टॉ, क्या इसको आप कहेंगे? टॉ डैश डैश टॉ एक्स डैश सी डैश मैक्सिमम. ठीक है जी. Now the third case in which you have both x and y axis, sigma 1 and sigma 2. So I will simply what you say, join sigma 1 and sigma 2. ठीक है जी. So this one is tau x dash y dash. Is this clear, guys? If you have any query, please ask me now. Is this clear? Is this clear? So now in this case, your absolute maximum shear stress is this one, tau absolute. Tau absolute maximum shear stress is your basically tau x dash z dash. ठीक है जी, maximum. And its magnitude will be sigma 1 minus 0 over 2. So this is sigma 1 over 2. Fine. एंड ओवर मैक्सिमम इन प्लेन शीयर स्ट्रेस क्या होगा? टॉ एक्स डैश y dash maximum that will be equal to, that one will be equal to sigma 1 minus sigma 2 over 2. Is this clear, guys? If you have any query, please let me know. So this was over case 1. This was over case 1. Now case 2. Just let me download this figure. Case 2. Case 2. In case of case 2, sigma 1 and sigma 2 have different signs. ठीक है जी? Sigma 1 and sigma 2 have different signs. Sigma 2 have different signs. ठीक है जी? So now for this, I can sigma 1 I keep it as tensile, sigma 2 I change it. So this is sigma 2, and in this case sigma 2 is compressive. Sigma 2 is compressive. Sigma 2 is compressive. Sigma 1 is still the tensile. ठीक है जी? Now you have principal stresses which are in opposite sign. So now let's redraw this figure. This one X and Z, it will remain and Z. This needs to be changed. So it is now compressive. It is now compressive. So into the element. This will result in the reduction. Similarly, here I have to change the sign. ठीक है जी? Is this clear? Is this figure clear? Now let's draw the Mohr circle. जी. ठीक है जी. Now first this one sigma 2 is compressive, so it is negative. So sigma 2 is negative. Sigma 2 is negative. So this point is my sigma 2. ठीक है जी. So this one will be ये क्या होगा जी आपका tau y z dash. Tau y dash z dash maximum. Next. Okay, good. And sigma 1 is, as we have said earlier, sigma 1 will always be greater than sigma. ठीक है जी. So this is my sigma 2. So this is your tau x dash and z dash. ठीक है जी. So this is tau x dash z dash. This is maximum. Next is xy. Now in this case you can see sigma 1 is positive, sigma 2 is negative. So we just have to let me draw this. So we just have to connect this. ठीक है जी. So now in this case this is tau x dash y dash. Tau x dash y dash maximum. So in this case now absolute and tau maximum in plane shear stress will be equal to tau x dash y dash maximum and the value is sigma 1 minus sigma 2 over 2. ठीक है जी. Sigma 1 minus sigma 2 over 2. Is this clear, guys? Is this clear? Let me export this. Now we are going to quickly do a numerical related to this. Okay, guys. Now we are going to do this numerical. Example 9-10. The point on the surface of the cylindrical pressure vessel is shown in the figure. It is subjected to the state of the plane stress. We have to determine the absolute maximum shear stress at this point. So this data is given to us. This one is 16 megapascals and it is 32. So sigma 1 is 32, sigma 1 is 16, and they are both tensile in nature. So what you can do, you can also draw the Mohr circle just like this. Case 1, sigma 1, ठीक है जी, and then this is sigma 2, and this one will be sigma 1 minus sigma 2, ठीक है जी, and you will get the absolute maximum shear stress. Absolute maximum shear stress will be this one, sigma 1 over 2, that is 32 minus 0 over 2, 16 megapascals, and maximum in plane shear stress will be this one, which will include sigma 1 and sigma 2. Sigma 1 is 32, sigma 2 is 16, so 32 minus 16 over 2, so you will get 8 megapascals. Guys, is this clear? The numerical is very simple. You just have to draw the figures just like the figure which we have drawn earlier, ठीक है जी? And then we can just put the values of sigma 1 and sigma 2 and we can directly get the answer. Is this clear?
Yes, sir.
They're not clear. So if such question, if such question comes in the exam, the best thing is you should draw the figure the way I have drawn, and then you just put the values. ठीक है जी? So you do not actually need to remember any formula. Let me show you again. So this is that first case. Now here we are given sigma 1 as 32 megapascals, sigma 1 sigma 1 is 32 megapascals, sigma 2 is 16 megapascals. ठीक है जी? So corresponding to sigma 2 I have drawn the Mohr circle. ठीक है जी? 0 to 16, 0 to 16. Then corresponding to the second sigma 1, it is 32. So 0 to 32. So this one whole is 0 to 32. Now I will draw absolute maximum shear stress. That is, I have to draw the third Mohr circle, which is x and y. So I will connect sigma 2 to sigma 1 and so on. ठीक है जी? So our absolute maximum shear stress in this case will be this one, tau x dash z dash maximum, tau x dash z dash maximum, which just includes sigma 1. So sigma 1 over 2, so 32 over 2, 16 megapascals, and maximum in plane shear stress will be this one, tau x dash y dash. So sigma 1 minus sigma 2 over 2, sigma 1 is 32, sigma 2 is 16, so 32 minus 16 over 2, 8 megapascals. ठीक है guys, is this point clear? Guys, now one thing with this over plane shear, this plane shear stress chapter is finished. Now, from the next time, Dr. Numan will take your classes for next 4 weeks. ठीक है जी? I will share all the lecture. ठीक है जी? Handwritten notes as well, the solved numericals, the figures which I have drawn, and the book you already have it. So I will also give you some practice problems for your what you say, to enhance your concept. So in case you will have any queries, any questions, you can directly email me at my email address kasimkhan@uit.edu.pk. ठीक है जी? My email address is ठीक है? So for any queries, you can contact me through my email, and my WhatsApp is also with the CR. Is this clear, guys? I think you guys
Yes,
are
sir.
quite tired today. Okay, guys, thank you very much for your time. And inshallah, I will see you after 4 weeks with the next chapter, that is plane strain transformation. Thank you very much for your time. Have a good time. And I will hopefully see you after Eid now. Okay, guys, thank you.
Allah Hafiz, sir. Allah Hafiz.
Thank you. Allah Hafiz.
Allah Hafiz.